Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Yasmin Fatimah with ID number 410142037. Today I will going to discuss a real life problem and then we will solve the problem by using the graph method and the ruler method by using GeoGebra. So I have a problem here. The transportation company must distribute 1,200 packages of the same size via two haul trucks. Truck 1 loads 200 packages for each haul and truck 2 loads 80 packages for each haul. The transportation costs for truck 1 and truck 2 are 400,000 rupiah and 200,000 rupiah respectively. Even though the available cost to transport 1,200 packages is only 3 million rupiah, we need to calculate the minimum cost of transporting the packages. So first thing to do to solve this problem, we have to make the mathematical model. And then, so we will represent, here we have let X be the number of packages transported by truck 1, and Y is the number of packages transported by truck 2. And then to make it easier, we make a table that contains the information of the problem. So we'll have this information here. And then from the information, we can make the minimum model. We obtain that the objective function fx, y is equal to 400,000 x plus 200,000 y. And the constant function, the first constant is 200x plus 80y is greater than or equal to 1,200. And we can simplify it to 5x plus y plus 2y greater than or equal to 30. And the second constant is 400,000 x plus 200,000 y is less than or equal to 3 million, and we can simplify it to 4x plus y less than or equal to 30, where x is greater than or equal to 0 and y is greater than or equal to 0. And then we will move to GeoGebra. First, we make the equation. From the constraint, we have that 200x plus x dy is equal to 1,200. The first equation is, then, and then the second equation we have, we already simplify it, so we can put the simplified one. So 5x plus 2y is equal to 30. And the second equation is 4x plus 2y is equal to 30 also. And then to determine the visible area, we input the inequality. So we have the intersection of the inequality. So on the first inequality, we have 5x plus 2y plus greater than or equal to 30 intersect by 4x plus 2y less than or equal to 30 intersect by x is greater than or equal to 0 and intersect by y is greater than or equal to 0. And then we will have the visible area here. And then we need to determine the intersection or the corner point. We will use this feature, intersect. And the first is intersection between the equation 1 and the x-axis. We get that the intersection point A, that is 6, 0, and then we determine the intersection between equation 2 and x-axis. We get point B, and then the intersection of equation 1 and equation 2. We get it here, and then we will solve this by ruler method or line of inquiry. So we input the objective function, that is 400,000 x plus 200 y equal to k. So, and then we need to change the interval of k. Okay, so I will change it to 0 until 4 million. And the next, we will play this and see which one is the first point that intersect with this equation. Okay, as you can see, it intersect with point A first, and then intersect with point B and C at the same time. So we check here, if intersect with point B and C, the value of the objective function is 3 million, and if it intersect with A, the value is 2,400,000. So from this, we already know that the minimum value of the problem is 2,400,000 rupiah. But to make it sure, we can check it by inputting the value section point. So first we write the objective function of x and y equal to 400,000 x and plus 200 y. And then we use the spreadsheet here. If you do spreadsheet here, this point, and then this is the value, and the point is, the first point is 6,0, and the second point is 7.5,0, and the third point is 0,15. And the value, we can put FA here, and FB, and FC. So from this, you can see that the minimum or the smallest one is 2,400,000. So we can conclude that the minimum value is 2,400,000. Okay, so the minimum cost of transporting the package is 2,400,000 rupiah. Okay, that is all from me. I'm sorry if there is any mistake. Wassalamualaikum warahmatullahi wabarakatuh.